Rahim, in the name of Allah, the most beneficent and the most graceful. Ladies and gentlemen, Assalamu alaikum. I am here today on behalf of Pakistan Society of Civil Engineers. Today the society is starting a new series of discussion, which we have named Panel Discussion. The purpose of this discussion would be to dissect those issues which are problematic for the civil engineering industry. To achieve our purpose, we would be inviting leading experts on the topic that we will choose for discussion. It will be based on an interactive session through Q&A, which would be anchored by a person who is well versed in that subject. Ladies and gentlemen, today's topic is design and construction of tall buildings, and our anchor person is Rizwan Mirza, who will conduct the proceedings. Before I introduce to you Rizwan Mirza and his guests, I have to make an important clarification. Some associates of PSCE who knew that society is going to start a new series of program requested me to change today's topic in light of recent flood that has hit Pakistan. Indeed, they are right. But when I was asked to change the topic, it was too late because I and my team had already made the preparation for this program after a hectic hard work of 2 months. Again, if we had changed the topic, it would have required another few weeks for the preparatory work. Therefore, we decided to continue our program as planned, and inshallah, next program that we shall present would be on the floods in Pakistan. Now coming back to the introduction. First of the co-host, Rizwan Mirza is himself a civil engineer who possesses to date more than 40 years of experience as a structural engineer. He is qualified from UET Lahore in 1980, worked few years in private sector before starting his own practice as a consultant, which he is continuing till date. Being so versatile in his design experience, he is considered a reputable, reliable, most competent and a responsible professional structural engineer. Our first guest, Naimur Rahman Durrani, who is well-known structural engineer in Pakistan. Within the fraternity of civil engineers in Pakistan, he commands tremendous respect. He has not only worked in Pakistan but overseas as well, particularly in Europe. His career spans over a half century now. He has worked on several types of civil engineering projects as consultant, designer, and at the level of construction management. His experience comprises power sector projects, residential and commercial buildings, multi-story buildings, and nuclear power plant. He lately developed expertise on design of deep excavations, which adds versatility in his experience, which is already so rich. Durrani Saab is based in Lahore and is self-employed, running his own consulting company. Our second guest, Muhammad Efron, a civil engineer qualified from UET Lahore in 1999, having more than 22 years of experience, most of which is in construction. Today he is representing the construction industry and the developers. His expertise include project planning, system development, development of new projects, particularly the residential and commercial buildings. Currently he is working as a project director for a private group involved in development of tall buildings. Our third guest is Dr. Muhammad Efron. He has been invited as a geotechnical expert. He qualified from UET Lahore in 2008 as an undergraduate civil engineer, where he continued till he completed his master's. Thereafter, he proceeded to Japan, from where he got his doctorate in civil engineering in 2014 from University of Tokyo. His expertise is in dam design, slope stability, landslides, geotechnical investigations in general, and particularly for power projects. He is an expert on the usage of geotechnical instruments and sensors. He has 40 research papers to his credit. Dr. Efron is also self-employed like Durrani Saab, and he is also running his own consulting company based in Lahore. Our last and fourth guest is Khurram Tahir. He is based in Australia. He got his undergraduate degree in mechanical engineering from UET Lahore. Then he proceeded to Australia where he became Chartered Mechanical Building Services Engineer. He has joined today as Building Services Engineer, having more than 18 years of experience in Australia, Pakistan, Sri Lanka and Indonesia. His area of expertise are design and project management, mechanical, plumbing and electrical services, building information modeling and fire engineering. Khurram is working in Australia as Principal Building Services Engineer and Design Director in a private enterprise. Now, this was a very brief introduction of our guests. Now it's over to Rizwan Mirza to start the proceedings of this panel discussion. Thank you very much.
I would like to begin with Mr. Naimur Rahman Durrani. And my first question would be, if you could explain terms like low-rise, tall, high-rise, and very tall buildings or skyscrapers.
Tall buildings traditionally are defined by their height, which I don't think is the sole determining factor and does not appear to be quite correct. Now, traditionally, tall buildings that achieve significant heights are classified in two additional subgroups. A super tall building is about 300 meter high or taller, and a mega tall building is 600 meter tall or taller. Now, I would define a tall building in which special systems for its stability, lateral movement, occupant comfort during high winds, special systems may consist of one or more of the following. I mean, if one or more of the following are required to stabilize and brace the building and reduce its lateral drift, if one of these systems are required, then the building is, I would qualify it as a tall building, irrespective of its height. 400 feet high building, which is slender, meaning thereby that its height to width ratio is about 6 or 7, located in a high wind area, and it's just 400 feet high, it would definitely be classified as a high building because it would require outriggers and mass tune dampers in order to meet the serviceability requirements in high wind. Now, the basic systems that are used by engineers all over the world for additional stability and reduction in lateral drift or outriggers, bracing systems, mass tune dampers, or a variety of these.
My next question is part of a two-series question. First of all, I want a brief answer. What are the basic forces that act on a tall building? Just name them.
Okay. The basic forces acting on a tall building are almost the same as to which medium height buildings like 20 floors or 25 floors are subjected to. But the severity of the forces does increase. Now, for earthquake forces are strength level forces and are designed as such. Earthquake forces vary with the square of the height of the building, whereas the wind forces vary with the cube of the height of the building. Wind all over the world is considered to be the primary factor defining the tall building. Firstly, because its value increases very rapidly. Secondly, earthquake does not require a surface level design because maybe it occurs for 30 seconds or 1 minute or whatever, and people are, not very, they go out to come where somewhere. But in a high wind area with apartments on upper floors, surface level winds may be of 3 to 4 hours duration. Let me define what the service level. The service level wind is the mean wind with a return period of 1 year. Now, normally the strength design wind is one which has a 2% degree of uh,
Accidents.
yes, in a period of 50 years, it can exceed that value in 50 years. But this is a 1 year mean. I hope that answers your question in terms of what are the forces.
Yeah, it does. Uh, if you have not already answered this question as a part of your earlier answer, my next question was, how would you compare and contrast the action of earthquake and wind forces on a reinforced concrete tall building?
Yeah.
My emphasis is on comparison and contrast.
Now, as I said, earthquake forces will be designed for strength level and not for service level. But the wind forces will be designed both for service level as well as strength level. This is the major difference between the two. The additional requirements in stabilizing the structure are almost the same for the two. But the fact is that the acceleration of the wind induced forces is defined by this graph. The graph number 1 is for offices and 2 is for apartments, which are very important. Okay, I'll just run through what I've meant. I mean, these are ISO generated graphs, and on the left is the acceleration in meters per second, and on the bottom is the frequency of the fundamental mode of vibration of the wind force. So you can see that if you have a frequency of say 1 cycle per second, you cannot exceed a threshold of 0.04 meters per square second in an apartment. But if the frequency is lower, then you can go much higher, up to 0.14 meters per second square. Now, when the earthquake forces can be reduced by several systems, but this also requires perhaps more than the earthquake, the necessity to reduce the lateral drift because of the comfort of the, otherwise the penthouse apartments will remain empty. People will hate to go and occupy them. By the way, we use 5% damping for reinforced concrete structures for earthquake and 1% of critical for this wind. So that further complicates the matters. Do you think I have answered the question, sir?
Yes, you have. Uh, how do the structural systems of tall buildings change as they become taller?
Okay. You will see there, uh, on the left is the number of floors. Like for instance, say 50 floors. The preferred system is a shear band all around the building and an outrigger. I will define the outrigger later by giving an example of a building we designed in Islamabad. So all these are defined here. The systems you would be using, like a bundle tube or a external frame or a tube in tube. Most of this owes its existence to our Dr. Fazlur Rahman, who at the time he died in 1956 was a Pakistan, but is more remembered now as a Bangladesh. He was the one who worked for Skidmore, Owings and Merritt and developed all these systems for tall buildings. If you want to, I think it's pretty clear on this slide what systems would suit what height of building or what number of floors. If there is some specific question, I can answer that.
No, I think that's about it. I would now like to move on to our next guest, Dr. Irfan. Dr. Irfan, please switch on your mic. Could you please tell me if and what difference is there between geotechnical investigations and interpretation for a tall building and for a building that is not tall? Broadly, that is. Of course, you can't give a sweeping statement, but in general.
Thank you very much, Rizwan Sab, for the invitation and for having me here. And to answer your question, I would want to take you a step back and think about first the objective of engineering analysis in general, whether it be geotechnical or structural or whatever. So whenever what we want to do in engineering analysis is basically we are trying to do to predict the behavior of the structure. And how do we do it? There are two components to it. One component is the mathematical formulations in the form of theories and formulas that we use to find any particular behavior of any particular member. And the second thing that is important is the inputs that you have to give to that mathematical formulation. So these are the two distinct things that we first need to understand, which are important in any analysis, any kind of analysis that we are doing. Now, I think to answer your question, we first need to understand the difference that geotechnical engineering is compared to, let's say, from the structural viewpoint or the others. When we talk about the mathematical formulations or the theories that are used in geotechnical analysis or the structural analysis, they are pretty well established. They are specified in the relevant codes which can be used. The problem and the difference what comes in case of geotechnical engineering or the application of geotechnical engineering is that how to decide more suitable input values for those to be inserted in those mathematical formulations. Because when we talk about structural engineering, the uncertainty is comparatively less. We can pretty reasonably establish the material properties of structural members. But when we talk about geotechnical things, the to establish the material properties is a real challenge. So that's the first thing that we need to understand. Now, coming to your question, your actual question, that what's the difference? That in order to understand the difference, so the basic process is the same for geotechnical investigation of a low-rise building or a high-rise building. The real thing that we need to put more effort is to determine the geotechnical properties with more certainty, with more which are more close to the reality. That's the real challenge. Now, we can, of course, do that. There are modern tools available, but obviously they come with a cost. Now, when we are talking about geotechnical investigations or the geotechnical process for a low-rise building, the cost that might be required for the soil investigations for a low-rise building to determine the material properties, the soil properties with that certainty might not justify for that particular project. On the other hand, that cost might be worth spending when you talk about the high-rise building. So that's the basic difference in a broad way, you can say. Then comes some other things, and what those other things are, like okay, what we can do in case of how we can establish those material properties in a better way. Basically, what we need to do is we can do again two things. One thing is that we can determine those material properties inherently at the site. So that's the first thing. There are certain types of testing which can be done at the site, which can enable you the measurement of geotechnical properties in a better way. So that's one. But there are certain properties that cannot be established with that much certainty at the site. So what you need to do in that case is that you have to make sure that you take the samples out from the soil in an as undisturbed manner as possible. So that's again a subjective thing. We can never procure a perfectly undisturbed sample, but we can at least try to get a sample which is as undisturbed condition as it was maybe hundreds of feet beneath the ground surface. So this is where the extra cost comes in. So in a nutshell, to answer your question, it's always a benefit cost thing, that whatever amount we are spending on the geotechnical investigation, whether it be a low cost or a low rise or a high rise project, whether it justifies the benefit that we can get out of it. So I hope I have probably answered your question.
Well, it partly does. As a practicing engineer, I myself feel that the level of, as you said, it's a trade-off between what you spend and what you get. There's a point which you think is a balance point. The level of reliability that we achieve in generally adopted quantum of testing and the type of tests that are undertaken, do you think that would be adequate for a building, as Mr. Durrani was talking about? Especially if we are not sitting over a rock. We may be very fortunate if we are sitting over a rock, but we may not be as fortunate at some locations. So when the pressure bulbs become deeper, would there be additional modalities involved, or would you be dependent on national maps which do not exist in Pakistan, or what? I don't want to go further than that. It's a question, in fact. I don't want to, go beyond a question.
I think, again, probably to answer your question in a more holistic way, let's look what we actually try to achieve in geotechnical investigations for any project, for that instance. Basically, in my opinion, there are just two things that we try to determine in a geotechnical investigations. One, we try to determine the nature of the soil, that whether it be clay, sand, rock, whatever. So one, we try to determine the nature. And second, we try to determine its characteristics, its properties. So these are the two objectives. Now, as far as determining the nature of the soil or the deposits is concerned, that's relatively easier. That can easily be achieved either through geophysical means, we can do it with a reasonable certainty in some cases, or by drilling, any kind of drilling, we can achieve that with a reasonable certainty. The real challenge comes in determining the properties or the characteristics of that material. So that's the real challenge in actual. Now, again, the question is, how can we do it in a better way? How can we do it in a way which is cost beneficial for the project in question? That's the real question. Now, as I was discussing earlier, so looking at for example, the Pakistani industry or the Pakistani practice that is there. So I think it's not a Pakistani problem. It's like the problem of almost all the developing countries with limited budgets to put into these kind of things. We rely on methods and technologies which are pretty outdated. Let me give you one example, which can probably elaborate what I want to say. In Pakistan, the core focus of our soil investigation is getting the soil parameters from the standard penetration test. So that's basically what we try to do. Now, if you just search on the internet, you would find some really good research papers which explain the inherent deficiencies in the standard penetration test. And some of the very famous people in geotechnical discipline, they go as far as publishing papers with the captions, how the standard penetration test is not standard. So just to elaborate that thing. The problem here is that when we perform, for example, the standard penetration test, we are talking about large strains. We are disturbing the soil and we are actually imposing large strains into the soil. Now, look what happens in case of a building. Now, it's probably a little bit of a segue from the current discussion, but I'll try to connect it back. What happens in case of a building? Generally, when we are designing foundations of a building, we typically say that there are two common modes of failure. One is the shear failure, other is the excessive settlements. But if you would try to search for practical examples of a shear failure where any structure would have failed because of shear, you would probably hardly find any practical examples of this. I could only find one case history with a shear failure based failure there was a silos and that's probably in some Canadian code that I found. Now, the problem is that our focus in soil investigations in the local industry is a lot on determining the cohesion of the soil, determining the friction angle of the soil, which we are determining from the standard penetration test. And that standard penetration test is large strain. But our actual concern particularly in case of high-rise buildings, is the settlements. Now, what is the process of determining the settlements for that matter? Now, you are putting load on the soil, and those settlements are gonna be caused, or they can be evaluated based upon the modulus of elasticity of the soil that is there. Like for unit stress, how much strain can be produced in the soil. And that is the real thing. That is the real, you can say that is the real thing that we need to determine. And as accurately we can determine the modulus, the more realistically we can predict the behavior of the structure. And that is where the cost benefit things would also come. And the modulus itself is a very long debate, and I cannot go into that because even the modulus changes with the strain level in the soil, and it's a separate discussion, so we cannot go there. But the point I'm trying to make is that the basic philosophy of our soil investigation that we do here, which is based upon penetration testing is something which I believe is flawed, particularly when we talk about high-rise buildings involving millions, if not billions, of rupees of investment, and we are not willing to invest in the soil. And there's a very famous saying that in the geotechnical community that you are going to pay for the soil-related matters, whether you know it or you don't know it, whether you pay it in advance or you pay it during the life cycle of the project. You're going to pay for that. So the point where I started was that the real thing is determining the properties of the soil in a more precise way. And as precisely as you can do, the more benefit you can get from it. Just to sum it up, and probably what I feel is probably we in our local industry are not that forward looking, because of which we want upfront benefit, generally speaking. And because since we want to get upfront benefit in cost, we are not willing to invest more at the time of soil investigations, and we pay a lot more in the construction or in tackling the failures in the long run, in the design cycle in the life cycle of the project. So probably if that answers what you were asking.
Thank you very much. I'll come back to you in a while.
Thank you.
Stay with us. My next question would be to Mr. Hassan Malik. Please switch on your mic if you could. With so many tall buildings mushrooming up in the country.
Rizwan, can I intervene, please?
Yes, please.
Rizwan, I think you did not notice Hassan had raised his hand for the question. Probably he wanted to ask Dr. Saab some question. So I don't know whether.
Okay, before I ask my question, let him ask his question to Dr. Saab. Please go ahead.
No, I think Rizwan Saab, I can continue with the things because the things I wanted from Dr. Saab during the question, he elaborated in detail in answer to your question. And I will just supplement in combination with the questions you are just going to ask me with respect to the mushroom growth. Please go ahead and complete your question, and I will club both the things in the same thing.
My question is very simple.
Okay.
So many tall buildings around us, mushrooming up around us. Are we really prepared as construction industry?
In simple words, no. Because there can be a complete session, a complete session encompassing all the various aspects which really we need to do for doing the complete infrastructure development or developing the building codes, the practices which need to be adopted, like Durrani Sahab in his part was telling us about the structural thing, and Dr. Efron was briefing about the geotechnical investigation. Even when we start with the tall buildings and the high-rise building, this is a total different type of structure, and this is a total different type of project management, and this needs a totally different type of attitudes towards building the tall buildings. And this starts with even site selection. At the moment, unfortunately, you also know, and all of us know about this, this location of tall buildings is mainly governed by the investors in Pakistan. This is very unfortunate. First of all, the site selection is being done based on the locality, irrespective of what are the impact of these tall buildings on our environment and our locality where we are going to do that. And again, the question I was trying to add into Dr. Irfan's debate was that we are paying for the on-surface per square foot of the land and not going to invest on what it is deep inside that square foot of the land. And the behavior of a tall building is totally different from a 2 or 3 story building or even a 10-story building, its impact is not only on knowing what millions of the questions can be added into this, but you have gone through a lot of soil investigations, and a lot of soil investigation companies are working in Pakistan, and you can hardly name few of them who are genuine soil investigation companies who are capable to give the exact parameters of soil investigation which are required for a tall building or even a regular building. Only 2 parameters are mostly covered: type of the soil and bearing capacity. And there is hardly a debate on other parameters, even for the shallow foundation. All this is, I think this is a subject that Durrani Saab and Irfan Saab should comment in a better way. But I, being into the field of execution and project management, this is the thing which we encounter, being the developers or being the engineers who are operating. And we are the first one when our employers or our clients, and the very first thing after buying the piece of land, that is getting the soil investigation, and people are saying, okay, spend just not more than $1 billion and just get it done, because this will be the thing which will be required to be submitted to the authority with the foundation design. And nobody at that time, even nobody, Tahir Sultan Sahab, know that there had been very promising building in Central Business District, and we were working on one of the project, and perhaps we were the only one who were considering. First of all, I consulted you as well, Dr. Rizwan Sahab, through other structural engineers, to set down the parameters for the soil investigation. If we are planning to build a building higher than 500 feet in the middle of the Lahore, what really are the parameters we are looking for the soil investigation? And all the other 5 plot owners, they just got it done for less than $1 million, and they had submitted their soil reports and even their design without engaging any structural engineer or any geotechnical engineering. This is how much we are prepared.
Okay, this is very painful indeed. My next question to 2 of you, probably any of you can answer it, Mr. Khurram or Mr. Hassan. Is there any special equipment or machinery that would be required or beneficial to the type of tall buildings that we are going to have now than that were required as a minimum before? Any of you is free to answer it.
Yeah, I can supplement it simply with respect to the construction. Definitely, yes. This is about transporting the materials, and what are those equipment with respect to the service of the building and construction of the building. Khurram can elaborate it in detail.
Thank you. Khurram?
Sure. When it comes to the, okay, first of all, I just want to have a disclaimer that whatever the views I'm going to give it, it's solely my view, and considering the construction industry practice I have done here in the local market as well as in the overseas market. So there's no plan of disrespecting anybody practice or opinion in the Pakistani market. So in terms of the construction equipment and the machinery, I will let Hassan Saab to debate on it. But in terms of the MEP equipment side of the things for the tall building, we have to think totally out of the box side of the elements, because we are dealing with high pressure pipes, we are dealing with fire pumps, which has a high head pressures. Okay, and currently what we have noted in the Pakistani market is that a pretty standard or cookie cutter approach is being adopted in most of the MEP equipment selection side of the things. Whereas the international codes such as NFPA, or in some cases we have also consulted BS code, where NFPA is a bit silent. We have noted the code gives us the provision of going in terms of high flow rate, in terms of high head, but when we have gone to the market to get the pricing, the market has responded by saying, okay, these kind of equipment is not available in the Pakistani market, or even if you want to go into that, the cost will be exponential. Okay. So, and by the way, we are not talking about a super tall or mega tall building. We are talking about a normal tall building,
Yeah.
and we were trying to optimize the cost of the equipment. But when the feedback has came, we have to start compromising our design. And a very common approach, what we have heard from the market, this is how we have been working in the industry for long. And we being a bit new to the Pakistani market, obviously we have to respect that. But when we have pushed few of the suppliers, yes, they can provide some equipment from the Middle East market, but then they start charging the premium in terms of the supply and installation and testing and commissioning of the equipment. As Hasan Sahab rightly pointed out, we are dealing with most of the builders and the investor where for them return of investment is the most important and the priority item. And instead of going along with the consultant or the individuals who are professional in the field, they sometimes listen to like 5 or 6 different vendors who has a different experience without knowing the background, what made them to make those kind of an experience. Okay, in fire related elements, I have noted, and we as a company also noted, that there's a long way for Pakistan to go for. Here, definitely, Rizwan Mirza Sahab, you will add up, Naeem Durrani Sahab, you will add up, but fire engineering is a pretty complex process for tall building, mega tall building, or super tall building, and it comprises of both active and passive fire protection. Active, we deal as an MEP consultant, whereas passive shall be dealt by the structural engineer. But without naming anything, we have been working on quite a bit of a project. And when we ask a question, simple question like such as compartmentalization, smoke compartmentalization, or a fire compartmentalization, we need fire curtain, we need smoke baffles, we need barriers. We get a bit of a silence, first of all, from the designers, and we also get a bit of a silence from the investor point of view. So I would say in terms of availability of the materials, yes, can be sourced out. Obviously, someone has to pay a premium if they want to go on to that part. But I personally believe that still we are a bit long way where we can have where we can generate a demand to reduce the cost of those equipment. Okay. So that's coming from my MEP point of view. But in terms of the construction equipment, in terms of the machine, you take an example, say, for example, 65-story building. A project might come up in future, or maybe 75-story building. Location of the MEP plant room. Say, for example, if we have a hotel sitting on the top of the building, and hotel generally, if it's a 5-star hotel, they want to go on the path of a central chill water system. Where exactly I'm going to install the central chill water chillers and as well as the cooling towers? Do we have a mobile crane which can lift that certain capacity of 6 to 8 ton at the top of the building? That's one question. Do we have helicopter transportation, which we can find in the Middle Eastern market and also in the Australian market? Okay. Or I can tell you what I feel is, if the simplest solution we're going to hear is we will put those chillers in the basement and we will run a long pipe from the basement all the way up to probably say maybe 50th floor where the hotel is going to get accommodated. So we have to think outside the box. We have to think bigger than what we are currently doing. Good thing about Pakistan, tall building concept is what 30-story, which is not exactly the tall building in the international market, okay, which is low to medium rise building. So we are still safe, but when we consider the CBD project, which is coming up in future, when we consider a building, I know there's a building happening in Karachi, when these kind of buildings are going to come, we have to change our approach. And challenge with MEP equipment side of the thing is, MEP equipment is a cycle-based equipment. Based on the certain equipment, you need to change after 20 years, maybe 25 years, after 30 years. And I can very confidently say that a lot of investors, a lot of clients, a lot of even designers, they have not going to that path to consider how we're going to replace this equipment, which we're going to maybe put via the tower crane in a dismantle form at the top, how we're going to take it out in future. So I think what Hasan Sahab has started, the local councils, the local authorities, the local governments, they have to join their hand together in terms of architects, in terms of professional consultants working in the industry, to come up with a framework that which can, maybe I'm saying too much, which can be applicable at a province level, not at a smaller level, where a harmonized sort of a national construction code is applicable, which can be applicable in majority of the cities or majority of the state. And most of the tall buildings are coming only in Karachi, Lahore, Pindi, and Islamabad, or maybe few are coming also in Peshawar as well. So, but there need to be some sort of a standardization approach moving forward. Over to Ehsan, sir.
Okay, Ehsan, probably my next question should be to you. Please switch on your speaker. Ehsan, unmute your speaker, please.
Yes.
My next question to you is, safety is always a concern. For excavations, it's a concern. For working even beyond 4 feet of height, it's a concern. On a staircase, it's a concern. But is it particularly a concern when you work on a tall building, because we know wind velocities are high, the heights from which you can fall is very large. Are we aware as a construction industry? Generally, are people aware? Are they doing enough?
Again, unfortunately, no. Perhaps on the end of the day, it will be said that all the pessimist questions coming to me, although we are dealing with the things. Despite that, most of the time I have to say no, but still, as Khurram said, at the moment we are dealing with 30 stories, and these are we are calling them high-rise in Pakistan. And for those, safety practice in Pakistan is unfortunately, there had been a very good project in the heart of the city. That is a very lavish and very well-known project. I was also part of the project, and it was very unfortunate when we listen about number of human lives lost in the project.
Yes.
And that is really an unfortunate thing. And that was perhaps biggest investment in the town at that time. The engineers, the professionals, the owners, nobody was bothered about the safety of the human life. When we are talking about tall building, I usually say that even designing and planning the mobilization for a tall building itself is a project. Tall building is a project, and to plan and design it is itself a separate project that should be dealt accordingly. As Dr. Efron said, and Durrani Sahab said, and Khurram said, there is a total different mindset required for just thinking of going high. When you are working on what international safety practices say, when you are going 4 feet or lower than that in excavation, or you are working 6 feet or higher in elevation, you just need to be careful that there is a risk involved.
Yes.
Because when you are moving above than a normal human height or going below than a normal human knee level, then there is a risk involved that a man's life is at risk due to the fumble, due to the fall, due to the hitting and all that. Only the height is not the only constraint in construction. We are even not aware of basic safety practices in our construction industry.
Yes.
And even you are say the most normal construction in our industry is single or two-story houses. And the most dangerous acts you see in everyday life, there is a loss of life when someone's steel bar holding a labor holding the steel bar hits live LT cables and then losing the life, and sometimes the whole lot of the labor is losing the life. These are the very simple things. These are the panic. And unfortunately, the developers and all the things, the people who are investing on the projects, they are not ready to take care of the safety of the life, human life, into the project. Not even during construction, but even during the service of the project. This is very unfortunate. We are far behind in considering safety in everyday life. This is very unfortunate. And still, but I would not say that all are not considering. Still, we can see there are good developers, there are good people. We can see on certain projects, there is hope and light seen on some projects where people are following the safety practices, where we can see in the morning prayer, people are being briefed about their life, the importance of their life, and their importance in the contribution, what they are actually going to do to this project and to their families. So the things are there. These are our people who are working safely and safely cautious in the Middle East and in the international market. But unfortunately, this is due to our national dilemma and our national approach that people, when they are landing back home, they are ignoring all these things.
Yes, yes, this is very painful. Assam, my next question is that nothing would make Mr. Durrani and Mr. Efron happier than finding a material which has less weight, so that their structures and the foundations become lighter. I don't want to go into the detail, but lesser the weight, the better it is, generally. So, you've been in the market for quite some time now. Do you think we need to get out of the inertia that we are in at the moment and really look for new materials which have not so far found their way into Pakistan, so that we can reduce the weight onto our buildings? This becomes significant when they become taller.
Of course, yes. And not only the material, but the method of construction, like we have been always discussing. This is not only the superimposed load or the service load on a tall building or any structure, that's dead load of the structure itself.
Yes.
I think that is the source of your question. In fact,
Yes.
the use of the lightweight materials and high strength materials,
Yes.
that reduces the dead weight itself, which otherwise is the most undesired thing, that there is a minimum dead load required to make it stable.
Yes.
That should be there, and there is a minimum strength to keep the building in service and intact. But beyond that, it is not desired. So definitely we should have lightweight and high strength materials. And in, like we say, there's a construction industry which runs 200 more industries. When on a national level we decide to go vertical construction, there should be a setup. There should be a parallel industry setup to process these lightweight materials, high strength steel, alternate materials, or into the prefabrication, or into the off-site construction, or into the modular construction. So that sometimes when you're just dealing with the concrete, and to produce the concrete, there is a minimum criteria to have certain specific gravity, certain size of the particle, and that makes it heavier than, which actually is required for the service of the building. Like in the slabs or all these things, maybe for the design, Durrani sir can better explain, if the basic frame, the columns and beams are made in a different way and the slabs are infilled in a different way. That these are the everyday discussions we are dealing in the design offices. So these are the things, if alternate materials and alternate ways of placing those slabs in place is available, if the good equipment is available, construction method is available, then why Durrani Saab will not like to have those in place to design and incorporate in his design? And if the good equipment and the way to get the undisturbed sample deep and the deeper to the rocks is available, why Irfan will not like to use those in his geotech investigation? So these are the equipment, as I said earlier. Just planning, designing, and preparing for the tall building is itself a project, and our investors, developers, our implementing agencies, our councils, they need to understand it, that this is a totally a new setup which is required, and that should be there.
Thank you very much. I'll come back to you.
Sure.
Mr. Durrani, I have my next set of 2-3 questions for you. You already answered part of them in your earlier discussion. I want a formal answer from you to the question that what are the critical response parameters that need to be controlled in a tall building?
If I may, I would just add something to what the previous speakers said very shortly.
Okay.
Now, the first query is from Dr. Irfan Saab. Now, yes, the budget for source investigation or other things rises as the accuracy increases. But we can offset it by getting input which saves us cost. Like, for instance, soil structure interaction. We can save a considerable amount of money in seismic analysis by considering this. What we need is radiation damping of the soil. The radiation damping is about 35%. Remember, I said for concrete buildings, we use for the concrete itself 5% damping. Now, 35% damping is a huge premium, actually. Similarly, yes, as you mentioned, you need high strain shear modelers. And of course, one of the fields in which geotechnical engineers specialize is liquefaction analysis. How if the conditions at the site are such, the geotechnical engineer has to certify whether the soil will liquefy, whether it is sand, loose sand, high water table, whatever. The other question is from Asansa. Now, when we look at a high-rise building, say 800 feet high, you can see the elastic shortening of the columns.
Yes.
You can even watch it now, which runs into several inches. And remember that all columns are not uniformly loaded, right? What sort of system should we adopt? Should we stop construction at some stage and try to make up what is the difference, so that at each level we get this same level at the north side or the south side or the east side or the west side, because a lot depends on these slopes, and that I hope you'll elaborate once you get a chance. Coming back to compartmentalization for fire, that is a routine system for even 3-story buildings, not to talk about high-rise building. Eurocode specifies that you should, beyond this area, you should compartmentalize it so that fire in one area does not go and affect the other. Now I come back to what are the requirements that we need for carrying out acceptable seismic structural analysis. Now, things have changed over the last quite a few years. If we have, I'm sure Rizwan must have used it, that we go by the 1997 two-period response spectrum.
Yes.
I'll show you that. That should have been history by now, but we are somehow unable to break the shackles of that spectrum. And that spectrum is this one. Now, when you see this spectrum, you see that it does not cover tall buildings. Very simply, tall buildings have a period of 3 to 4 seconds. Even a 500 or 600 feet building would have a period of 6 or 7 seconds. Now, how do you locate it on this two-period spectrum? One, there is a requirement of a factor called TL. I don't want to, confuse the audience with this, but this somehow does not exist in our building codes. Even the latest building code does not have this TL factor. They haven't determined it. Apart from the fact that they are using outdated response spectra, this TL is missing. I mean, you can't design tall buildings without this TL. No way. If you go to the USGS site, you'll find this TL for each and every town or city of the United States. So, what we need is a response spectrum which is specific to the site or at least to the area and contains elements which are very definitely of importance to the structural engineer to come to a conclusion about its stability, storage drift, other things. And unless we have that spectrum, we can't do it. We can maybe approximate some things, but to your question, I say no. We don't have the wherewithal to adequately design a high-rise building with the data available at the present and also in the latest 2022 Pakistan Building Code. Does that partially sort of answer the question?
Yeah, it does. What do we do then? We go back?
Yeah, we move on.
Next.
Sorry?
Next.
Next. Now, I'll just look at some simpler things which will help understand the later concepts which are slightly complicated. Now, what systems should we use for a tall building which can adequately serve the purpose and keep the story drifts, especially in wind, within limits, so that we design for the occupant, not for ourselves. And the occupant, if he feels awkward, then we are gone. Anyway, there is a system called outriggers, We used it on a building in Islamabad. And basically what it does is that it connects the central core with the peripheral columns through two-story high beams or shear walls or trusses or diagonals, so that the cantilever mode of deflection of the shear wall is sort of converted into a cantilever plus uh, shear mode of lateral reflection. Now, when we connect the core to the peripheral columns, sway reduces to a combination of cantilever and shear mode, thus reducing lateral drift. Now, just to give you an example, I mean, the first building is a shear core building without any outriggers. And we say that drift is 1. Well, take any unit, is 1 for this building. Now, if we put an outrigger right at the top, the drift reduces to 1/4. If we put an outrigger, say almost in the middle, the optimum point, if you have just one, opportunity to provide one outrigger, the best place is 0.56 height from the top. But anyway, this one is something like very similar, and this drift reduces to 1/6, which is a huge reduction. Then if you have the luxury, if you can provide this at 2/3 of height, then you reduce it by 1/9. And if you have two outriggers, one in the middle and one at the top, it reduces the drift by 1/16. And if you have the luxury of having two outriggers, not at the top but in the middle, you reduce it by 1/25. But I was just going to give you an idea how it helps. And when it helps, it reduces the wind acceleration, which is a product of the square of the circular frequency and the displacement. Displacement, if it reduces, even if circular frequency does not, the acceleration will be within limits. This is very simple. I mean, there are two outriggers, and it shows you where the kink in the shear core lateral movement comes. But when it hits the outrigger, it stops going further and reverses more. Things like that. Now next. This is a practical example actually. It's a 400 feet high building in Islamabad. So it's complete now. We used outriggers on the mechanical floor, which was fortunately 9-meter high. And you can see that at the plan. Now, in the plan, you have the mega column, the span below the outrigger. You have mega columns with about 20-meter spans and sizes of about something like 750 millimeters by 2.4 meters. Now, you can't take them up into the apartments, unfortunately, because they will be a huge. Now, in addition to stabilizing the structure, it can act as a transfer structure, which is very common because the first 5-7 floors are normally malls all over the world. And then you have to suddenly go into smaller spans and smaller columns. this is the outside. I just want to show that you need space. You need to sacrifice space, or you need MEP space to put this out again. All right. Now we talked about the two-period spectrum. The current ASC 722 does away with the two-period spectrum. It is this green graph. Now the purple one is the 716 two-period. You can see how I mean, it's about 25% it lies below that. But that the 722 spectrum includes soil structure interaction effects, for especially for site class D soils, which are soft, and if they are subjected to large earthquakes, you are in trouble. Now the 722 spectrum, in that the soil parameters FA and FV, which we are used to, have been removed. Actually, you use it as it is. You don't have to multiply it with anything. Now the other one is MPRS, which means multi-period response spectrum, and which we are more in need of, because the maximum period of the structure may not lie within that two-period response. This is very important. I mean, we may be designing buildings at maybe half of the response. Now, if we go further, we have designed a building in Islamabad in which we adopted a site-specific response spectrum, which is the blue one. This one. This is now the maximum period of the building is about 2.75 seconds, and the peak of the spectrum is at 2 seconds. Now, had we used the upper one, like zone 4 IBC, zone 4 means near fault, and it's right up there, but it would have underestimated by a factor of about 2 the response at the fundamental period. You can see the curve, the traditional curve coming down, and at the point of where you require it, it is almost not helpful. If you look at the UBC3 site class SD, zone 3, which if you look at the spectrum for this site in Islamabad, it looks like a zone 3 thing, but not exactly. But now you can see that the zone 3 standard spectrum lies about 3 times below the peak of the site-specific spectrum, and so on and so forth. Now, from this, what we want to achieve, that what we need is a study which includes the soil and flattens the area of interest. I mean, we are interested in this spectrum. Why? Because we are not interested in 1 second or say 0.5 second. Because this is a long period building. It's a 600 feet high building. These spectra do not relate to those. So what conclusion I can draw is that the latest building code of Pakistan, 2022, can only be applicable in its original form for buildings maybe up to 300 feet or something like that, not beyond that, in which the periods fall within its capacity. So the question was, do I have the wherewithal to design a substantially accurate high-rise building? The answer is, I'm afraid, no. At the moment, we don't have. Unless we do this for sites where we think are hazardous. This is a long drawn process. There is a probabilistic hazard analysis behind it, and a lot of seismology of this. But the fact is, it gives you a result which, to my mind, it gives me confidence that if I take this design to a reviewer, I can defend it with some confidence. Not just say that I based it on a two-period response spectrum and this is what I did. So I'm afraid this is all I had to offer on this question. If Rizwan Saab wants further clarity or anything else, or any other speaker, I'm here
Thank you
to.
very much, Durrani Saab. I wish we could go on and on. The time would freeze and we could all listen to you indefinitely. But I'm a little bit short of time. We would, with the help of Allah, continue this process. Dr. Tahir, I have heard people say that when it comes to geotechnical engineering, numbers don't really matter. It's the color of your hair that matters. You can tell by looking at the soil what type is it. And I hear a lot of people talk about software that have come in, and I've seen people modeling soils using those software. As you said in response to the last question, the input that we provide to that software would give me the guarantee of a reasonably plausible answer. My question is that is a young engineer, say with an experience of say 6 months to 1 year or 1.5 years, equipped barely with a software, qualified to handle, model slopes, embankments, soils, foundations, just banking on these numbers?
Rizwan Saab, I think it's a very, very important topic that you've touched upon. I think this is something this is kind of a plague, which is not restricted to geotechnical engineering, and it's probably spread to all parts of engineering these days. That is our over-reliance on softwares. In my opinion, one needs to, in my personal opinion, softwares are a very, very useful and a helpful tool. Yes. They can help you speed up the process. And not only this, as per my personal experience, they can also help you extend the knowledge, your own limits of knowledge. Because probably there is a particular topic that I have learned up to a certain limit, and if I'm operating the software and there is a particular input that I have to give, which is something that I have never seen in that particular form, that actually pushes me to know more about that input first, try to develop a good physical understanding of that input, and then put it in. So that's why we can extend our own knowledge through the softwares as well. But blindly using those softwares without having a physical understanding of the inputs that you have to give is, I think, it's never gonna work. It can backfire big time. I see a lot of young engineers these days, and you get to hear even this sentence from them, कि सर मैं फलां सॉफ्टवेयर चलाना जानता हूं,
Yes.
as if it's like riding a motorcycle or a bike, that I know this, or I know how to fly a kite, for example. So particularly now trying to restrict myself to geotechnical engineering, I think it's more important. Why so? Because in case of soil, the second level complexity that is added to the soil is that the same soil will give you different physical parameters in a different state. What I mean by this is the same soil that is deposited at a particular project site, as soon as the moisture condition changes, which can simply be because of the leakage of a sewer pipe nearby, its characteristics are going to change. So until and unless you don't know the physical meaning of those things, or let me give you another example, like when we talk about, for example, the earth retention systems, if you talk about those, so the same soil, when you are designing an earth retention system, the same soil can have a totally different behavior in the short term and in the long term. So if you do not have a good physical understanding of what C or a C dash that you are putting in the software, or the friction angle or a critical state friction angle or other parameters, you don't have a good understanding what is the physical meaning of these things. If you do not have that physical understanding, you can never be a good applied engineer, in my personal opinion. So I think that tells you my opinion about this topic.
Okay, thank you very much. My next question would be, in fact, encompassing a number of questions, and I am learning too from you. I'll summarize 2 or 3 questions. When it comes to tall buildings, it results with a smaller footprint, if the footprint is small, with large bearing pressures.
Tahir Khurram is back.
Sorry? Okay. When the bearing pressures are large and the building dimensions are such that the pressure bulb will be deep, so the settlements are likely to be high. So generally you provide a mat over the area that is available, and then maybe you provide piles. This is, I'm repeating the obvious. My question to you as an expert is that I'm involving not only particularly the plot underneath my area, but also the surrounding plots over which either the construction is already there or would be there in the future. Probably the danger will be mitigated because a part of my system is deep foundation, but not all that mitigated and not probably as properly understood, because a part of it is the mat, which is sitting right over the level of the basement. Just a broad answer from you, the bigger picture from you. I know I can't ask for a specific answer because your question is too broad.
I think you very rightly pointed it out. This is a big issue that we often ignore, and that is the influence of the influence of the load that you are putting on the soil on the adjacent property, if this is what you're asking, I believe.
Yeah.
So that's as you rightly pointed out, the whatever stress that we put on the soil is not restricted within your own property line. It spreads beyond the property line as well.
Yes.
So we have to be very careful in trying to understand that what existing structures are there. There are certain soils in which that stress is spread in a more wider area compared to some other soils. There are certain configurations in which putting a stress on a soil affects the nearby structures more. Obviously, since it's a broad question, so it depends upon the nature of foundation of the existing structures nearby, the levels between the two structures. So it depends upon a lot of things. But the short answer is yes, it does affect a lot, and it has to be taken care of in a real sense. And probably what needs to be done at the more at the administrative level, like as Assam just mentioned, the central business district, for instance.
Thank you, Doctor. You rightly pointed out.
My next question is to Khurram. Khurram, when it comes to tall buildings, let's say we are talking about a height of 200 meters or about roughly about 600 feet. What about fenestrations? What about air tightness? Does that need special treatment, special handling? Do we need special type of windows there or what?
Rizwan, this is a pretty good question. To me, this is a twofold question, and I believe Naib Durrani sir would be able to also jump into it and to contribute it from a structural engineering point of view. But my observation so far in the Pakistani industry is like in terms of what are the wind testing facilities available in Pakistan in terms of for a high-rise building. So far, in my practical experience, and frankly, my practical experience is far more less as compared to the teams what is sitting here. We are currently designing a 400 feet tall building. We do have few buildings sitting at 350 and around 300 feet buildings, but we haven't seen any sort of a wind testing facilities or wind test reports available for those kind of a building. And one of the building is sitting in a kind of like a valley. And when I say a valley, designing infinity pool on the top has a certain impact in terms of the wind side of things. I agree. The question is about fenestration, but it has to start from a basic testing facility from a wind point of view, and how we're gonna have an impact or testing of the wind on the facade elements, and how it's gonna contribute into its leakage and the tightness side of things. Okay. There are a lot of codes you guys know better than me in terms of dead and imposed load, code of practice for wind load, in terms of the fire precaution point of the side of the things. I haven't had a chance to get into a debate yet with the designer team on what we are doing about it. Okay, and definitely not stepping on the toe of someone else, but this is what we have been facing in the industry. In terms of the air leakage point of view, it has a huge impact from an MEP industry or on an MEP industry, because energy loads and energy demand and cost of energy, if the building is not properly sealed, if the building is not properly leak proof at a height, and it causes certain impacts in terms of the occupant comfort, it causes certain impact in terms of staying. If somebody is staying at a height of say 400 feet, if the leakages or if the proposed say for example curtain wall system which has been proposed on some of the projects have been properly tested under the wind loads, because I haven't experienced in Pakistan, but I have experienced few things in a super tall buildings in overseas market, but we have heard a lot of rattling sounds coming if the building is not properly sealed. Okay, it also creates stack effect impact within the building as well. Okay, and stack effect has a direct correlation in terms of um, building envelope and the height, because it creates certain air buoyancy differences. So if the air is keep on coming inside an occupant area or occupant zone, it will cause an air balance between the comfort zones and external zones. And if you have a damaging weight of say like even 50 kilometers, okay, if it's going to impact or going to hit the building at a height of 400 feet, it has a huge impact in terms of the occupant safety. It has a huge impact in terms of the occupant comfort side of the things. And same goes if we are unable to control air leakages rate, it has an impact of the MEP system designed for the building side of things. So yes, I would say uh, fenestration and air leakages to the building has quite a bit of impact in terms of how we design the building, how we design our MEP system, and the required testing is being done or not. But I personally, as a designer, haven't seen such kind of a thing so far in Pakistan. But correct me if you're wrong. You guys might have seen those one. But the project what we are doing is there is no consideration at this point in time. So I see this thing as a real challenge, because we are designing system by considering that say a double glazed curtain wall which is proposed for the project is going to handle all elements, and it will be a proper leak proof and airtight fenestration system.
Okay, thank you. In response to one of my earlier questions related to another topic, you talked about fire. And you said that these could be handled either actively or passively. In Pakistan, we have seen buildings which are not tiled by any stretch of imagination, taking a lot of toll in terms of physical damage to the building and to the people who occupied that building. Our civic authorities appear not to be really equipped to handle the types of fires that might occur in a tall building. What do you see happening then? Can we really rely on our fire extinguishing and this, detection systems alone?
Very good question, Rizwan Saab. What we have learned so far is best way of protection is a passive protection, because we are not having a reliance on any sort of an active system.
Okay.
Active system is all about detection. Okay, there is a fire happen, and then you go with the automatic sprinkler system. In the overseas market, what we have learned is the architecture, the structures, even the builders, they go on the path of passive protection as much as they can, and then they try to have a bit of a reliance or less reliance on the active system. However, under the fire conditions, say if somebody is sitting on 400 feet tall building at the top of the building, and if there is a fire happen and it has an impact on its on majority part of the building, the whole concept is how to get that individual safely to the bottom or to the assembly area or get out of the building. Majority of the cases, if we are unable to manage things from a passive fire protection, that's where we have to go and design the active fire protection side of things. But when it comes to the active fire protection, there's a lot of stuff we have to comply under the NFPA side of the stuff. Then we have a Pakistan Fire Code requirement, which is clear, which is mostly follow NFPA. But then we have a local authorities requirements as well. They ask for additional water storages. They ask for additional pumping systems. Okay. So if to make sure that if there is a fire condition, the fire protected areas, they can be sustainable, or they can be stabilized at least for 2 hours, such as fire staircase, okay, then fire evacuation lifts. Okay, then in super tall building, we also create refuge floor areas where we can bring occupants of the building which are staying at the top to the refuge area, and then they can be evacuated in a controlled manner, okay, toward the bottom. But at the same time, when it comes to the civic authority side, we're saying the important thing is the response time. One of the things which I have noted is like there is no definitive studies available. Like if there is a fire happen, how long the fire brigade department gonna take and reach to the building? And that is one of the important factor what we use in the overseas market in deciding do we need active system to be operational for 1 hour or do we need to be operational for 2 hours? Okay. But then other items are pump capacities of the fire department, Bowser capacity of the fire department, because in overseas market, we say a lot of street hydrants, which are connected to the water infrastructure, and they can continue pumping water to the underground water tank. And that basically is the suction side of the fire pump, and we will keep supplying water. But here in Pakistan, majority of the cases, what we have known, and because of the aging infrastructure, we don't get that continuous water supplies available. So going on the path of a tall building, it's a pretty good thing for Pakistani industry, but it has an impact. And we are very lucky, alhamdulillah. So far, there are no serious accidents has happened. But what we generally say is it's better, prevention is better than cure, that we should follow all the requirements of the applicable NFPA code requirement as well as the local fire department. But at the same time, the local fire department guys, they need to upskill themselves in terms of how they can support any building during the fire condition. Okay. Last thing what we noted is like when the fire brigade guys, they reach on site, how they're going to control the entire building. Because one of the most important thing is the evacuation. Yes, not suppressing the fire straight away. One of the first important items is to safely evacuate all the occupants of the building. And if it's like, take an example, if it's a tall building, it's a residential building, say on, say 60th floor, a disabled person is sleeping on his bed, how to safely evacuate that person. In terms of the travel distance, in terms of which lifts are going to operate or we're going to utilize fire staircase if that person is a disabled person. So in terms of when we like what I have seen so far in the market is like I haven't picked up any sort of a guideline when the fire brigade guy go into the fire fighting control panel, which is a panel which we created where all the active fire protection devices gonna attach. How to control that, how to continue running the staircase pressurization, how to manage the smoke transmission from one compartment to another compartment. Okay. So in overseas market, when the fire brigade guys, they reach to a building, they straight away go to the fire command center because they know exactly where the fire is. They exactly know how the fire warden are responding, where the individuals are sitting. So I believe that we need a bit more collaborative approach with the local authorities and try to understand where their actual limitations are, and then blindly follow NFPA rules or international codes, which are pretty good. We need to have some sort of a alternative option for Pakistani market, that how effectively we can control fire, we can control evacuation or safe evacuation of occupants and handle the fire. That's all.
Very, 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 very well phrased and I think comprehensive answer. My gratitude to all of you. What I like about this format, which is at the experimental stage, is that it's not a monologue, it's a dialogue. Many people are speaking, giving their points of view. They may be from different disciplines, but they are hearing the other person and they are giving their opinions. And we hope that everybody amongst us, the participants, understands and takes it in that spirit. If you give one opinion and one of our colleague differs with it, I think that is where the real strength of this experiment is, which we have started. So my final round of this session would be giving an opportunity to each participant of taking one or two lines only, because we have run out of time, about whatever we have forgotten to ask or whatever they think should have been asked. One or two lines. Let's begin from you, because you are already there. Your speaker is unmuted.
So, Rizwan sir, you're saying to me?
You phrase the question and you answer it. You have two lines at your disposal.
So, safety and safe living is important. It's very important. We understand international codes are important. We have a local councils, important. But my suggestion is we should not blindly follow it. We need to respect our local infrastructure. We need to respect our local capabilities, and we should design things around those as well.
Thank you, Hassan. Now I would request you to give us your last word. You phrase your question and you answer it in two lines.
I would just remind Durrani Saab asking a question from me and Irfan during his explanations in the second round of questions. I think the questions he asked from me and Irfan both need another 2 hours of the session to answer. Like we started in the beginning, that this is a beginning of a new beginning. So inshallah, we'll be having this experiment fine-tuned under the umbrella of PSCE and Sadia and Tahir Saab. They will be guiding us and pitching all the things, the infrastructure they are putting to bring these things. Definitely, there is a lot more topics to come up. And particularly about this tall building, like Durrani Saab's question about the elastic shortening of the columns, definitely even to say in one line for that particular question is perhaps I addressed in my previous term, that using the alternate materials and alternate methodologies, that is the way forward towards building the tall buildings. And this is a one thing which I think I would like to add in our upcoming such sessions. We add our expats into these sessions, and definitely there are a lot of expat Pakistanis who want to contribute towards Pakistan, but due to their limits and restrictions on all these things, they cannot travel, and this is a good medium to utilize this channel. We have good frequency with the people. So I think for this session we did a well effort today. Thank you to both of you, Rizwan Saab and Tahir Sultan Saab, and of course to Durrani Saab for being so patiently listening to all of us. We are just the kids in the market, and I think Irfan, being the youngest among us, did a very good job. Thank you very much. I have nothing more to ask.
Thank you very much. We have really run out of time. Durrani Saab, just two sentences from you. Your question and your answer.
I don't think I have much to offer, but there were some questions. How much experience should an engineer have before he is launched into high-rise buildings? So this question is quite subjective. It depends upon who the person is. I would hate to use a 5-year experienced structural engineer for a tall building, which is complex. I mean, you remember the earlier buildings and the iconic building of Barrier. They have a central core of about 30 meters by 30 meters. and they have one row of peripheral columns. I'll give that to a 3-year experience engineer. You do it. Because there's not much complexity in this. The complexity comes when there is an eccentric core or forces which are beyond your reach in a sense that with normal materials and with normal technology you can't achieve that. So that's about all. I mean, we need to work on that, and we need to work on our colleagues, the young engineers, to train them and to take up challenge.
Thank you very much, sir. Dr. Irfan, now your turn. Kindly be brief, if possible.
Yeah. First of all, thank you very much. It's a great opportunity for someone like me with probably no gray hair to learn and listen to all seniors like Durrani Saab, yourself, Malik Hassan Saab. Just one last thing that I believe we did not get an opportunity to touch upon, so I'll try to just say it in a couple of sentences. That is that as Malik Hassan Saab mentioned, and the role of geotechnical engineering generally in our market is simply restricted to the bearing capacity and maybe the nature of the strata. I believe, looking at the global practices, there is a strong need for the geotechnical engineers and the structural engineers to work together. And that is a very important challenge, particularly with regards to the tall buildings. Just one example, the most commonly known book for foundation design in Pakistani market is the book by Joseph E. Bowles. We just read its first page, chapter number 1. It mentions that in the design of foundations of any building, there has to be 3 people that are involved. One is the geotechnical investigation agency, whose role is simply to do the boreholes, take the samples out, and present the factual data. One is a structural engineer who has to design the superstructure, get its reactions at the foundation. Third one, which is missing in the Pakistani construction market, is a foundation design engineer. That foundation design engineer, who is basically a geotechnical engineer, his responsibility is to get information from that factual data from the geotechnical investigation agency and work in collaboration with the structural designer to design the foundation. I think as we intend to go tall, it's very important to introduce that role in the market and get benefit from it. So I think that's all from my side. Thank you very much once again.
Thank you very much, Dr. Irfan. It's back to you, Tahir.
Thank you, Rizwan. First, I would like to thank Rizwan for conducting this session so methodically and giving time to all the participants so equally. It had made the discussion very smooth, very continuous, and very purposeful. To tell you honestly, I am a bit speechless after this discussion, listening to this discussion. The scale, the quality of the discussion was a bit, I don't know I should say this word or not, a bit surprising for me. It is of the international level. And I am very glad that all of you spoke in English, though I and Rizwan, we had decided initially that it would be in our language, Urdu mix. Durrani Saab, thank you very much. Ahsan, Dr. Irfan, Tahir, thank you very much for all your input. It was remarkable, I must say. I'm pretty sure when this video will be uploaded on YouTube and on Facebook, you will see the comments, and the comments will speak about the quality of this discussion. After this discussion, I am a little worried in the sense, I really hope that those who are at the helm of affairs of building construction, they listen to this video carefully and they devise their rules and regulations for the tall building structures carefully and according to the discussion guidelines given in this session. So this is really my worry that hopefully somebody will listen and they will follow what you people have proposed and advised. So in the end, thank you very much again, Rizwan, for having such a balanced discussion. And I really hope to see you again on some other topic from the forum of Pakistan Civil Engineers, Society of Civil Engineers. And one thing I must appreciate that this is lastly what I'm trying to say, that what you people have discussed today, this has furthered the cause for which this society has created more than us, what we people are doing as a staff of PSC. Thank you very much again.